You are tuned to Iri-e-learning, and I am your host, Teacher. In this lesson on periodic table and periodicity, we will look at the trends of the Group 2 elements. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to explain trends within Group 2 and recall that Group 2 elements are also known as alkaline earth metals. We will start by identifying the elements in Group 2. Group 2 elements are called alkaline earth metals. As the name suggests, they are all metals. These elements, in descending order for Group 2 elements on the periodic table, include beryllium, magnesium, calcium, strontium, barium, and radium. It is highly unlikely that we would come across radium in our school laboratory. This is so because radium is highly radioactive. It emits alpha, beta, and gamma radiation. You can review the lesson on isotopy for the unit atomic structure to get more details about the particles emitted from radioactive elements. You may have noticed from the photograph that radium glows green in the dark. As a result, it was used to make glow-in-the-dark items such as dials for clocks. However, radium is dangerous if inhaled or ingested, meaning swallowed, because the radiation emitted can damage body cells. In fact, when in the body, radium acts similar to calcium. Hence, it is deposited into the bones, potentially causing bone cancer. We will now examine trends in Group 2. We will examine 6 trends in Group 2: atomic size or radius, shielding, reducing power, ionization energy, metallic character, and reactivity. Starting with atomic radius or size. First, we need to know what the atomic radius is. And by definition, the atomic radius or the size is the distance from the center of the nucleus to the outermost electron shell, as represented by the flashing arrows in the diagrams of our atoms to the left of the screen. Notice that the green flashing arrows representing the radius of the atoms increased in length going down the group. You may have also noticed that the radius of the atoms get larger going down the group because an extra shell is added to each atom descending the group. Notice that beryllium has 2 shells, 1, 2. Magnesium has 3 shells, 1, 2, 3. Calcium has 4 shells, strontium 5, and barium 6. Therefore, we can say that the atomic radius or size increases down Group 2. Here is a copy of the periodic table. Note that the Group 2 elements occur in the second column from the left. Recall from the lesson on the periodic table, each element within a group occurs within a different period or row. And the period number tells the number of shells that each atom has within a given row. For example, beryllium occurs in period 2, hence it has 2 electron shells. Magnesium occurs in period 3, so it has 3 electron shells. Calcium has 4 shells, strontium 5 shells, barium 6, and radium 7. Before moving on to the second Group 2 trend, we need to become familiar with the term nuclear pull. The nuclear pull is simply the strong force of attraction of the positively charged nucleus for the negatively charged electrons. Note that the nuclear pull is an example of an electrostatic force of attraction because it involves the attraction between 2 oppositely charged objects. In this case, the positive nucleus is attracting the negative electrons. The second Group 2 trend we will examine is shielding. Shielding occurs when inner lying shells of electrons block the attraction of the nuclear pull on the outer shell electrons. That is, the inner shells of electrons block or reduce the attraction of the nucleus for the electrons on the outer shell. So what is an inner lying electron shell? Well, the inner lying electron shell occurs between the nucleus and the outer shell. For example, if we are to look at beryllium, beryllium has a total of 2 shells. However, there's only one shell occurring between the nucleus and the outer electron shell. Therefore, beryllium has one inner-lying electron shell. For magnesium, magnesium has a total of 3 electron shells. However, 2 electron shells occur between the nucleus and the outer shell of electrons. Therefore, magnesium has 2 inner-lying electron shells. Calcium would have 3, 1, 2, 3. Strontium has 4, and barium has 5 inner-lying electron shells. Therefore, note that the number of inner-lying electron shells increases as we go down group 2. As the number of inner-lying electron shells increases down the group 2 elements, so does the atomic size. Therefore, we can say that there are 2 factors impacting shielding. Number 1, the atomic size, which increases down group 2, and 2, the number of inner-lying electron shells that also increases down group 2. Let us take a look to the atomic diagrams to the left of the screen. Observe the radiating red circles. The intense red regions indicate where the nuclear pull is strongest, and the faded or white regions indicate where the nuclear pull is weakest or non-existent. The nuclear pull on the outer shell electrons get weaker as the atoms get larger. That is, as the atomic size and the number of inner-lying electron shells increase. Notice that the intense red color extends to all the outer shell electrons on the smaller atoms, which means that the nuclear pull is great on all the electron shells of the smaller atoms. However, as the atoms get larger, the red color fades towards the outer shell electrons, suggesting that the nuclear pull is less on the outer shell electrons than the electrons on the inner lying shells. As the atomic radius increases down group 2, so does the number of inner lying electron shells. Consequently, the effect of the nuclear pull on the outer electron shells decreases due to an increase in shielding caused by the increased number of inner lying electron shells. Therefore, we can say shielding increases down group 2. It's important to keep in mind that shielding causes 2 effects. 1, it causes larger atoms to lose electrons more readily. And secondly, shielding causes larger atoms to gain electrons less readily. The next group 2 trend we will examine is reducing power. So what is reducing power? Reducing power is a measure of how easily atoms lose their outer electrons. Also note that atoms that readily lose their outer electrons are called reducing agents. Recall that as atoms get larger, the effect of shielding increases due to the increase in the number of inner lying shells with electrons. When shielding increases, the larger atoms lose their outer electrons more readily. Therefore, reducing power increases down group 2. Note, an atom becomes positively charged when it loses electrons. An atom with a charge is called an ion, I-O-N. The atoms gain 1 positive charge, that is, +1, for each electron lost. A positively charged ion is called a cation. The fourth group 2 trend we will examine is ionization energy. What is ionization energy? Ionization energy is the amount of energy required by an atom to lose an electron. As atoms get larger, they lose valence electrons more readily. That is, they lose electrons from their outer shell more readily. Therefore, as we go down group 2, it becomes easier for the atoms to lose valence electrons from their outer shell. So for emphasis, keep in mind that as the atomic size increases, so does shielding, which causes the larger atoms to lose outer electrons more readily. Therefore, if they're losing electrons more readily, then less energy is needed for a large atom to lose an electron. Consequently, ionization energy decreases down group 2. The next group 2 trend is metallic character. The metallic character is described by the physical and chemical properties associated with metals. Physical properties include luster, high melting point, high density, high conductivity, whether thermal or electrical, while chemical properties depend on the capacity of atoms to lose their valence electrons readily. As atoms get larger, they lose valence electrons more readily, thus increasing the chemical properties and metallic character. Therefore, metallic character increases down group 2. The final group 2 trend we will examine is reactivity. And as we learned earlier, the reactivity depends on the ability of the atom to lose outer shell electrons readily. And in the case of group 2 elements, it's losing those 2 outer shell electrons. So group 2 metals react by losing or transferring the 2 outer shell electrons to another atom, which is usually a non-metal. The larger atoms will lose their outer shell electrons more readily due to shielding, that is, the increased number of inner-lying electron shells that block the nuclear pull for the outer shell electrons. So as the atoms get larger going down the group, reactivity increases. Note that the group 2 elements, when they lose their 2 valence electrons, they form positive ions, which are called cations. And because they're losing 2 electrons, the charge they gain is 2+. So if we are to write the symbol for the cation, M representing the symbol of the element, and 2+ written superscript to the right of the symbol indicates the charge. So for the group 2 elements, we have beryllium, Be, 2+, when it loses its 2 valence electrons. Magnesium would be Mg2+ as a cation. Calcium, Ca2+. Strontium, Sr2+. And barium, Ba2+. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. All the following trends increase down group 2 except A. Shielding, B. Ionization energy, C. Atomic radius, D. Reducing power. The answer is B. Ionization energy. Question 2. Which statement is correct about the effect of shielding? A. Shielding increases as the atomic radius decreases. B. Shielding causes smaller atoms to gain electrons less readily. C. Shielding causes large atoms to lose valence electrons more readily. D. Shielding increases the reducing power with a decrease in the atomic radii. The answer is C. Shielding causes large atoms to lose valence electrons more readily. Question 3. Alkaline earth metals readily form ions descending the group. What are these ions called? A. Protons, B. Electrons, C. Cations, D. Anions. The answer is C. Cations. Question 4. Which list correctly arrange the following 3 group 2 elements in order of decreasing reactivity from left to right? A. Barium, calcium, magnesium. B. Calcium, magnesium, barium. C. Magnesium, calcium, barium. D. Magnesium, barium, calcium. The answer is A. Barium, calcium, magnesium. Barium is more reactive because the atom is larger with more shielding, hence it readily loses its 2 valence electrons. Magnesium has a lower reactivity because the atom is smaller than the other 2 and has less shielding, therefore will not lose its valence electrons as easily. Question 5. Which of the following group 2 metals would be the least reactive? A. Barium, B. Calcium, C. Strontium, D. Magnesium. The answer is D, magnesium.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.